right? That's what I would need. What type of equation is that? Quadratic. You could solve it using quadratic formula, right? And you could get an answer. I'm going to skip that because what I'm going to do is just say, hey, look, I know it can't be bigger than 30, okay? I know it can't be, so I'm going to use that as my max. But if you really wanted to find the exact domain, you would have to go up here and solve that equation. So what we have is a continuous function, right, on a closed interval. So what are we going to do? Derivative? Okay, derivative. A prime. What's A prime? 15 minus 1w, right? Minus 1/4 pi w. Everyone agree with that? What do you do with that? Set it to 0 and figure out where it's undefined. So where's A prime 0? Where's A prime undefined? Well, it's never undefined because it's a linear function. It's 0 whenever I set it equal to 0. So let me do that. Oh, I'm out of room. Okay, I need to start a new page. Everyone have that? Here we go. 15 minus w minus 1/4 pi w equals 0. What I think I'll do is I'll take the two w terms to the other side to make them both positive. I'll factor out a w from both. And I'll divide through by this 1 plus 1/4 pi. Does everyone follow that and agree with that? Now, just for our own kind of understanding of what that number is, let's get our calculators and just get a decimal approximation to that so we have some better understanding of what that is as a number. I'm getting 8.4, approximately. Wait, 8.4 is approximately W. Is that within our domain? Yes? Okay, now, this is a really important concept point here that I don't want people to miss. Because last class we ran into this question, and I never really answered it thoroughly enough in class. The question was, can't we always use the closed interval method? I mean, just find out where the derivative is 0, plug those in and compare them. What is the trouble with the closed interval method right now? With this problem, what's the trouble with it? Does anyone recognize what's wrong with our closed interval method? Look at our closed interval, 0 to 30, right? Didn't we guess at 30? Didn't I say in order to figure out what the actual end of the interval would be, you would have to solve this equation? Right? Doesn't the closed interval method require that I plug in the two endpoints and the critical number? And if I'm guessing at one of the endpoints, I'm not going to really know if I've got the minimum or maximum or not, right? So let me go back to this, and I want you to consider the following. Let's say that we were never given an interval, okay? Let's say this was an open interval. What would be the next step if this was an open interval? You would draw a number line, okay? You would plot, ooh, wow, that's really not straight. You would plot your point, right? Which would be 8.4. You would pick a point to the left and to the right and plug them into what? Derivative. So how about I take 1 and how about I take 10? What's a prime of 1? What's a prime of 10? So I go back to my derivative, which isn't even on this page. What would you get if you plugged 1 in, and what would you get if you plugged in 10? So I've got to go back to the derivative, which is right here. Plug 1 into that. 15 minus 1 minus 1/4 pi. That's still a positive number, isn't it? Yes? 13. So it's positive, right? Now plug in 10. If you plug in 10, you'll get negative. Yes? What that tells me back here is that my function, my area function goes up and then it goes down, which means that 8.4 is a local maximum, right? But why can I be assured that that's the only maximum? How can I be sure that the endpoints aren't higher? How do I know the endpoints of this function are not higher than that maximum? Well, but look at it though. Your function goes up then down. How could any point over here be higher or over here be higher? Wouldn't the function have to come back up? Right? Wouldn't it? This is the only place that the function goes up and then comes back down, right? At 8.4. Nowhere else on the function does it go back up. So it can't go back up to a higher point. Does this make sense or not? It's like you have a hump in your graph here. Yeah, now if you had additional critical numbers, you wouldn't be able to do it. Okay? If you had another one over here and it turned back up and then maybe another one turned back down, then you would have to compare the two and see which one gave you a bigger value. So I guess what I'm getting at is this. In order for you to truly have done the closed interval method, you would have had to have solved that quadratic equation that I showed you earlier to find what your endpoint had to be, and then use the closed interval method. But if not, if you want to avoid that, you could have used the open interval method and convinced yourself this is the only place you have a maximum by looking at this. Do I make sense or not here? No questions? So we have a maximum area when W equals approximately, or W is approximately 8.4, what, feet? And it wants the dimensions of the window, doesn't it? So what was the height? You have to go back to your formula for height. I think I remember, wasn't it like 1/2 W? I may be wrong here, going off memory. Whoa. Was that it? Okay. So plug in 8.4. I'm getting something like 4.2. feet. Is that all the information I need to know? Can you construct the Norman window off of just this information? Well, I don't think it asks for area, does it? It says find the dimensions of the window that will give the greatest possible amount of light emitted. So it just wants the dimensions. Yeah, see, that's all I need. This needs to be 8.4 feet. This needs to be 4.2 feet. And then the circle, remember, is just half a half circle like that? That's fixed, right? Because the 8.4 is the diameter. Well, if you can't figure out what the closed interval is, then you can treat it like an open interval and then look for local max within what's reasonable, right? Like between 0 and 30, we know that if it only goes up and then down between 0 and 30, that's the only place I'm going to have a maximum, right? But let's say it went up, down, up, down, up, down 4 times between 0 and 20. I wouldn't be real sure about which one would give me the max. I'd still have to compare them. This is a great problem that was asked. I know for a fact that I've actually given that problem on a final before. What was the area function? Before we took the derivative, what was the area function? Wait, hold on. W squared. Oh, I'm using W. I need X. Hold on. Minus 0.5 W squared. Keep going. What I'm doing is I'm graphing this is the area function. There it is. There it is, like this. Okay? That's the area. If you let W be 0, of course you're going to have 0 area. Over here, somewhere, remember I said you'd have to solve the quadratic equation to figure out where that is. It's just the x-intercept of a parabola. And then somewhere in the middle is our, what's that? Well, yeah, you could, as long as it was right. For this, you could. This one, you can just do the zeros. Let's see, it's 0. Just so we know, it's 16.8. That's where, that would have been the closed interval, would have been from 0 to 16.8. And let me just verify that we got the max. So extreme values right there, 8.4, right? 8.4. And the maximum area, which it never asked for, would be 63.01 square feet. I mean, I hope that when you step back and you think about, what calculus is about here, what we've really done in this problem is we've found the maximum of a parabola. Okay? Which you could actually do the maximum of a parabola in college algebra. It's the vertex. But in calculus, if it was a cubic function or a sine function, you can find maximums and minimums. And now what we've done is we've tied them to word problems. Okay, good question. Anything else we want to talk about as far as the homework? 4.6. 4.6, number 13? Yes? Okay. Yeah, like what's your initial guess? Is that what you're saying? All right, so this is